The first part of this video, I will once again go over the necessary functions to complete problem set 3. I will hopefully lay this out in a little bit easier to understand manner than last week, so hopefully this helps you complete your problem set. And the second half of the video, I will just do a little midterm review, but in R, to give you hopefully a better intuition and understanding of the concepts that you've gone over in class. So again, you can always find this code on the GitHub, and the link is here, and this is what it looks like for today's video. But I will just go like we did last week and just show you my RStudio code. So let's import the necessary data to complete problem set 3. So the first data set we're going to import is the receipts data set. And as you can see here, it's successfully imported. Then we will import the simulation data set. As you can see here, it imported. We also could see the first couple of rows using the head function as usual. Then we're going to import the dplyr package, although you don't have to actually in order to complete the first half of this video. So for problem 2, what we're going to do is create a log. And the way we can do that is to write the name of our data frame, followed by a $, and then a new column name, anything you want here. So it could be receipt log, receipts log, whatever you want to write, equals, and then the log function, and then inside whatever data we want to take the log of. So in this case, it's receipts. And so we just create this. And as you can see down here, after we read the head function, there is a new receipts log column. Now, question 2a in the problem set is asking to create a histogram of the receipts and log receipts. So you should be able to take this code, and I want you to just input the data yourself. Make sure there's a comma here. So whenever you write the data, df, and then receipts, you have to make sure that there's a comma after. So write that code in there, write that, and then add the log here, and then run it, and it should work. For 2b, you're just going to be analyzing the shape of this, I believe. So you don't need to use any RStudio code. For 2c, you want to compare the receipts and log receipts of the dfsim data, or the simulation data that we import. If you name it something else, of course, you're going to be writing something else. And again, you're just going to add the non-log data in the first histogram and the log data in the second histogram, and you're going to plot that. Again, remember when you write your data in there, make sure that this comma is there. And for 2D, you're actually going to use the summary function. There's a number of ways you could do this. You want to look at the mean, I think, for this question, so you could also use the mean function if you knew of a specific column that you wanted to see the mean for. Using the summary is nice because it will give the summary statistics of all of our data all at once, and then you can look at the means and compare that between the two. So that's 2D. 2E is using the sample data of log receipts and non-log receipts for n equals 100. And that is different from the problem we did in 2C because the simulated data is n equals 5. So just make sure that you remember that 2C and 2E are only slightly different. They're from the same data set, the SimDF data set. So I hope this code makes it easier to answer your problem set. You can just feel free to copy and paste this to your answer, but make sure to put in the data. So that covers what I wanted to go over for problem set 3. Now I will continue on to a little bit of a midterm review. It's more of visualization that I hope will help you remember some of the material that you've covered in class. You don't need to necessarily know the code, or excuse me, you don't need to know the code. This is all just to show you. So if the code is a bit confusing, try to concentrate on the visuals that I'll be showing you. So in this code here, I'm just creating a bimodal data. I'm using the rnorm function by just combine. Basically, what this does is combines two sets of data with different peaks. So this will create a bimodal data set, hopefully. So we'll run that, and as you can see, it creates this bimodal data set. And then I will do the same thing, but with a trimodal data set. So I added another rnorm function. So there's 3 different peaks here around different means. So in this bimodal case, the mean one of the peaks will be around -2, the other one will be around 2, and this one will be -4, 0, and 4. So let's run this line of code, and that's our trimodal data. And then what we can do is plot the data. So this is our bimodal example. And as you can see, it looks like it's bimodal. And then this is our trimodal example. And if you haven't noticed yet, when you're using this plot tab, you can actually cycle between different histograms that you've plotted, which is actually kind of nice if we wanted to run them at the same time. And so that's just a simple example of bimodal and trimodal and using the histogram function. Now I want to show you again skew. So we will be using this library called Gapminder. So make sure that you actually install packages Gapminder. This is a great data set that I think you should probably know about. It is the basic demographics and economic data for all countries in the world. So life expectancy, population, and GDP. And so this data is also a panel data set. So there's multiple years for each country. And I am just importing this data just to show you that what a skewed distribution looks like in R. So I am just looking at the GDP per capita, and what you'll notice is that there's a skewed right, long right tail in this data. So that is my example for the skewed data set. And now I want to move on to the normal distribution. So we can generate normal distributions in R, as I showed previously, with this rnorm function. So in the rnorm function, this first number is the number of data you're generating, and mean and standard deviation I think are self-explanatory. So I'm just generating all these different types of normal distributions just to show you the difference between the 3 of them. So there's a normal 0 to 1, normal 2, 1, and a normal 0 to 0.25 actually here. I'm just showing you different distributions. So we'll run that, and it looks like it successfully ran because now we have our objects up here. And then we're going to plot all of these distributions. Oops, it's not good. So we'll highlight them all. And I'm actually using the add true attribute in the second and third histograms, which means that it will paste it on the same histogram. They will be overlapping. So as you can see here, these are the different distributions compared with one another. And you'll notice that the normal distribution centered around 0, of course, will be this one. The normal distribution centered around 2 will be this green one here. And hopefully this gives you a better idea of the normal distribution plotted. This example in 3.2 is the normal distribution of a 0 and 1, but this time I want to show you how to plot the standard deviations as well. So we're going to generate a normal distribution 0 to 1 again, and we're going to generate the standard deviation of that. Of course, we set the standard deviation to 1 here, but because this is just generated data, our actual standard deviation, as I think you saw in the last assignment, is actually a little bit different than 1, but it will be close to 1. So if we run this line of code, normal 0, 1, and you want to see what it produced, you can just, oops, nope, that's not right. Normal 0, 1 SD, and it's 1.01, so it's close to 1. And so now what I want to do is show a histogram. So first I'll give you an idea of what the histogram would look like. It will just be a regular histogram, but actually it's kind of nice because with this function AB line, we can actually add vertical lines on our plot, on our histogram plot. And what I'm doing here now is putting that normal 0, 1 standard deviation inside of this function, so it will be exactly at the 1 standard deviation. And I want to also put it on the negative side too, to show you the normal distribution and by standard deviation. And I'm just also doing that with the 2 standard deviation line and the 3 standard deviation line. And I think what you'll notice is that for the 2 standard deviation line, all I do is I take the standard deviation and I multiply it by 2. And again, I want it on the negative side as well. And then if I want the 3rd standard deviation line, I put it, I multiply it by 3. So if we run all this line of code at one time, what you'll notice is that you see lines are now present. So again, you don't have to memorize any of this. If the code is confusing you, you don't have to watch this. I just wanted to give you a better idea of how you can visualize what you're going over in class in R. I will also show you how to generate a z-score by hand. So we're going to plot some more data around the mean of 100 with a standard deviation of 5. So we're going to run that, and normal 105, that object is now created. And if we want to look at the histogram of it, what we'll notice is that it looks normal and it's around 100. So it's exactly the data we wanted. But now what I'm actually going to do is get the mean and standard deviation for this data. And again, the mean and standard deviation are going to be around 105, but not perfectly. So let's generate that data. We can take a look at the data if we want. So normal 105 mean. Sorry, these are getting quite long, but as you can see, it's near 99. Normal 105 standard deviation. As you can see, it's near 5. So what I want to do now is actually generate the z-score, and I'll just show you the z-score here, and this is how you generate the z-score. So it's your observation minus the mu divided by standard deviation. So that is what I'm calculating here. So I'm generating a z-score of our data minus the mean divided by the standard deviation. So once I generate the z, what you'll see is that now the data has been transformed around 0 and 1. So that's why these numbers now are near 0 and 1. And now what I want to do is generate a histogram of this data. And I'm again using this AB line function, which shows a straight line, a vertical line on the graph, and I just want to show the standard deviation of z. And I'm actually adding text now, so this is just another new function that you might find useful. You can actually put text in the histograms. So I say 68% of data lies below this red line, which is what we can infer from the standard deviation. And that covers that. So I just want to finish up by showing you how to calculate a sample mean and calculate standard deviation. So this is, again, pretty basic, but I just wanted to show you it in R. we're going to generate a random sample, so that's what sample.int function is. We're going to generate 10 samples between the numbers 1 through 10. So let's generate this xi. As you can see here is 10 numbers between 1 and 10. If we were to set this differently, sorry, that didn't work. Let's not set that. So if we just generate, let's just generate 10 numbers. What we're going to do is put this data into a data frame. So that's what asTbl is. And well, actually, asTbl is for dplyr, but I think you'll understand it after I run this code. And then we're going to rename the column. We're going to rename it xi. Originally, it's value. So I'll show you what that looks like right now. So when you run that line of code, now we have a data frame up here. The data has been converted to a data frame. That's what I wanted to do. So now we can actually look at it like a data frame as well. And you'll notice that here are our data. So now what I want to do is calculate the deviations from the mean. So I want to create a new column like we have been creating before and like we use for logs. So what I want to do is create this new column called xi mean. So that will just be the mean of the xi, so of the data. So if you look here, now that has been created. It's the same for every single observation because we're taking the mean of everything, but I just wanted to show it there. And then we want to take the deviation, so we are just squaring. We are just taking each observation, so each xi subtracted by the mean, and then squared. So that's what this line here does. And let's go back over to here, and what you'll see is that now we have this deviation column. And so what it's doing is 4 minus 5.5, so that's 1.5 squared. 1 minus 5.5, which is 4.5 squared, right? So that's all that's doing. So that just wanted to give you an idea of what deviation actually represents. Now we're actually going to just sum those deviations. So we're going to create a new column here as we've been doing in each of these steps. We're summing the deviations here. Now we will calculate the number of observations in our data set. So this is just 10. And we do that by creating this new column, and then we use the length function, and then we select that data. And so now we should have the number of observations. So it's 10 for each observation. And now we can actually finally calculate the variance and standard deviation. So the variance, we're creating this new variance column here. That is just taking the sum column, so xi underscore sum. And I actually need to make that quickly here. So xi underscore sum is 82.5. So it's 82.5, that's right here, divided by the number of observations, which we just created, minus 1. And so that's our variance. So now we should have a variance column. So that's our variance. And then we will calculate the standard deviation by just simply taking the square root of that variance that we just calculated. And now that will also be in our data frame. So this example was just to show you how we calculate the deviations, actually more than anything. This over here I didn't actually necessarily need to do, but I just wanted to show you a little bit how you can calculate this in R. And if we wanted to check our answers, whether they are correct, all we have to do is, of course, use that standard deviation and variance function that is built into R. So if we look at our standard deviation, it says 3.027, and that's the same there. So we were correct. The last two things I want to show you just very quickly here are the law of large numbers example, and the central limit theorem. So this head counter, what you're seeing here, is actually what is called a user-created function. And so this whole time in R, we've actually been using functions both built-in and from different libraries, but I'm going to probably get into this into greater detail later in the semester, but you can actually create your own functions as well. But don't worry too much about this because it's a little bit complicated, but just run all of this code. And what you'll see here now is that you have this function here. And once you have that function, we named it head counter. So counting the number of coin flips that land on heads. And so after we've created it, we can actually just use it like a normal function. And so we just write the name of the function, which is head counter, and then in it we put in whatever attributes that we created. So in this case, it's times. As you can see here, times equals 1 is the default setting. And we will do 10 coin flips. And so what this will do when I run it is count the number of heads in that coin flip in a set of 10 coin tosses. So if I keep doing it, what you'll see is that it has a different outcome each time because it's a different experiment each time. And so what I want to do is to actually do this 1,000 times. So I'm creating a list called all experiments, and that will have nothing in it. And like for the extra credit problem, what we'll do is we'll do a for loop with 1,000 iterations. And what we're doing is doing this head counter function and counting the number of heads for each time we make a toss. So if we run this, what you'll notice is that the all experiments, sorry, we have a lot of data now here. We have well, I can just show you on a graph. We have the all experiments data now, so I'm just gonna create an X and a Y, and then I'm gonna plot it. And what you'll see is that I think the professor has a similar slide in his review. You'll see that as we increase the number of tosses, the proportion of heads gets closer to 0.5. So you see here there's some outliers, and then slowly but surely we are getting closer to the actual mean. And lastly, I'm going to show you the central limit theorem in action. So we're going to create 3 empty lists. And like we did in the for loop for the extra credit problem, we are going to just iterate over those lists in a for loop. So we're taking the N100 empty list that we created, and we are actually putting in a coin toss, a number of coin tosses, and then we're going to use our head counter function divided by the number of tosses. And what we will see when we run this is that we've generated a bunch of data, and then we run the histogram down here. What you'll see is that this histogram will show you that we're slowly converging to the normal distribution. So the data with low observations, so low number of n, will be the blue and the green, so they're not really taking the shape of a normal distribution, but you can see when we crank it up to 100 observations that it looks like the normal distribution. In any case, these examples were quite complicated for code, so if you are having trouble understanding, don't feel like you're missing out on anything. That these examples are just to show you how you can implement what you learn in class in R, and I just wanted to show you that. So if you're interested to learn more, ask me about any of the code, please feel free to reach out or come to my office hours on Thursdays at 2 p.m. In any case, See you in the next video.